Hello, this is Mr. Manley. In this video we're going to talk about reference angles. Let's begin by looking at this equation. Sine 40 degrees equals 0.64 approximately. Maybe you know by now that if I were to add 360 degrees so that I'm at 400 degrees, the sine of 400 degrees is also 0.64. This is the nature of coterminal angles. If I subtract 360 degrees, I get the same result. So we have that. And I want you to consider, what does it mean when we say that these angles have this values? What does it mean that the sine of 40 degrees is equal to 0.64? One perspective on this is to think about the XYR definition of sine. Sine theta is y over r, which means that if I place a circle on an XY axis and then I rotate through an angle of 40 degrees, the place where that angle intersects the circle at 40 degrees has an x coordinate and a y coordinate. And the circle itself has some radius. So what it means that sine 40 degrees is equal to 0.64 is that the y coordinate that I would get here, how high is it above the x-axis, over the length of the radius, will be equal to 0.64. So that's what it means that the sine of 40 degrees is equal to 0.64. And that's why if I rotate around another rotation and I end up at the same place, I have the same sine value. And I can do that in an infinite number of ways, forward and backwards. Now consider this. If I were to rotate, so here I go to 40 degrees. Now if I continue to rotate around over this side, this point over here has an xy coordinate, and its y coordinate is going to be the same as this y coordinate. You can see that. They're both the same distance above the x-axis. Now stop for a moment and think about, what angle would that be? What angle would that be that has the same y coordinate? I bet you could figure it out. Think about it for a moment and see that the sine, you'd be able to say that the sine of 140 degrees has the same y coordinate as the 40 degree angle. So it's also going to be 0.64. So I'm going to be able to say that the sine of 140 degrees is 0.64. And just one more thing to consider would be if I took this angle around, and went down here opposite the 40 degree angle, so that if I'm opposite, where am I at? I'm at 180 plus 40, 220 degrees, right? That's 220 degrees down here. And then this y coordinate down here is the opposite of this other y coordinate. So with that said, would you understand that I could make the statement that the sine of 220 degrees is equal to negative 0.64? So under this idea of reference angle, all these angles have the same reference angle. This angle and this angle and this angle all have the same reference angle. Now, what is that reference angle? That reference angle is going to be found in between the terminal side of the angle and the x-axis. So let me mark these off here. So here, this is the reference angle for the 40-degree angle. And then look over here, this is the reference angle for the 140-degree angle. And this here is the reference angle for the 220-degree angle. And they all have a reference angle of 40 degrees, because this is how we define reference angle. The reference angle is the angle between the terminal side, and let's try and really be explicit about marking that off. The terminal side here is a terminal side, and the nearest x-axis. Nearest x-axis. Let's go over to the 140-degree angle. There's the terminal side. And what's the angle between that and the nearest x-axis? And then for the 220 degrees, and the nearest x-axis. And in all those cases, the nearest x-axis is 40 degrees away. Never talk in positive or never talk in negatives. Always talk in positives with reference angles. We don't care what direction we're moving to get to the x-axis, just how much. And then this leads us to another statement that the trig value of an angle, the trig value of an angle is equal to the trig value of its reference angle or the opposite. And we saw that opposite idea earlier, right? So we're getting a little bit cluttered here, but maybe you can still follow that we've got up here, we had the 40 degree at 0.64. The sine of 40 degrees, if you recall, was 0.64. And it had a reference angle of 40 degrees. An angle of 40 degrees has a reference angle of 40 degrees. And then this angle down here, the 220-degree angle, it also has a reference angle of 40 degrees. And its sine value, you might recall, was negative 0.64. So that's where this idea of the opposite, the value of its reference or the opposite. So it might be the opposite sign, depending upon its location on the graph. So here, if I'm asked to find the reference angle for 660 degrees, I'm going to conceptualize that on a circle. Starting at the positive x-axis, I'm going to rotate around. Once is 360. And then half more, that's going to get me to 540. And then keep going until I get to 660. So I'm just going to add 90 to 540, and I'm at 630. So 30 more degrees, somewhere around there. And that's what I think is really useful to do, to really represent where is this angle on the circle, this 660-degree angle. And then I've got to think about the definition, which is the angle between the terminal side and the closest x-axis. So I need to know what's that angle there. And if you kept track of things, you would know that that angle is 60 degrees. So here's another one. Negative 56 pi over 15. You might not like this because it's radians. But I actually think that makes it a little bit easier. Because first of all, I'm going to convert this to a mixed number. That's what I would always recommend for these. So this one would be 3 and 11/15 as a mixed number. Pi. Well, we know that pi is half of a circle, right? So I'm going to go around. I'm going to start at the positive x-axis. I'm going to rotate in the negative direction. And then every half circle is equivalent to pi. I've got -3 of them. So there's 1. Keep rotating. There's 2. Keep rotating. There's 3. So I went -3 pi. And I'm going to continue around 11/15 more. Well, that's going to be almost another half circle, right? Or thereabouts. So somewhere in there, maybe. Now consider this. If I went 11/15 of half of a circle to get to that terminal side, then very clearly, what is it here? How much is going to get me back to x? Obviously, 4/15. So the reference angle here is 4/15. Just one thing that I haven't commented on yet is that the notation for reference angle. So there's a notation for angle typically, right? Theta. And then for a reference angle, often the notation that we'll see is theta, and then we'll see what looks like an apostrophe is equal to 4/15. The way that we read this, not just for reference angles, but anywhere in mathematics, when we have this, what looks like an apostrophe, the word for that is, we say prime. So the way that I'd fully read this is theta prime. And that's a pretty standard way of referring to a reference angle as theta prime.